Hey everyone, I hope you all are doing good. In this lecture, we will be covering the binomial theorem in detail. This is going to be a tricky concept to understand, I'll be very honest, but I'll try to explain it first on the board and also give explanations using animation. So I think that will make things a lot more clear. Okay, so let's just try to understand what is binomial word, right? The idea is binomial is just an expression with two terms. So I've given three examples over here. For example, a plus b, 2x plus 3y, and x plus y, right? Just a very few examples. Okay, so the binomial theorem is basically the theorem to expand this term, right? The idea is basically that whatever x plus y is to the power of n, we kind of find a general formula for it, right? So first, what we're going to do is, instead of me giving you guys the entire formula from the very start, I'll try to give you guys the pattern of how that formula really arrives and how that formula really works, right? So let me give you guys this question. The idea is, your goal is to expand this term for any n without multiplying by hand. So instead of me giving you the formula directly, I'm giving you this question to do it. So let's just start doing this one by one, right? For now, my goal is to expand it for any n. So just like we did it for the previous lectures too, right? I'm going to try to solve it for some few values of n, and I'm going to try to see or find some sort of a pattern if I can, right? And based on that pattern, I'll try to derive the formula, which is going to be a binomial theorem in this case. Okay, so let's just take a look at n equal 1, x plus y. Let's take a look at x plus y to the power of 1, right? In this case, it would simply be x plus y, right? I hope that makes sense. So I can say 1x plus 1y. Let's take a look at x plus y to the power of 2. Okay, in this case, it will be x square plus 2xy plus y square. Okay, let's take a look at x plus y to the power of 3. In this case, it would be x cube plus 3xy square plus 3, sorry, I should say x square y plus 3xy square plus y cube. This will be a third one. I'm just adding the coefficient 1 to these values x, and I'll explain why. Fourth one would be x plus y 4. It would be x4 plus 4x cube y plus 6x square plus 6x square y square plus 4xy cube plus y4. Once again, I'm just adding the coefficients to these values. Okay, so these are the formulas for the first 4 n values, right? So x to the power of 1, 2, 3, 4. Okay, I want you guys to try to pause the video and then just try to understand if you can gather any pattern from this. Okay, so let's just start understanding the pattern, right? What I'm going to do is, I'm going to grab all the coefficients from these values that I get and write them on the side. Okay, so for the first one, for n equal 1, you get 1, 1. For n equal 2, you get 1, 2, 1. For n equal 3, you get 1, 3, 3, 1. And for n equal 4, you can notice over here, it's going to be 1, 4, 6, 4, 1. Don't you see some kind of a pattern happening here? Like, you can probably see that this tree is kind of resulting in something. Okay, and so now let me tell you what's actually happening, right? For any value of n, I'll just directly give the formula for now. This value is basically c n comma k. Any value, any coefficient in this formula is simply c n comma k. It's just the combination formula that we covered in the last lectures. Okay, and what's the value of n? N in our case, n is the row, and k is the index. Starts at 0. So the idea is that if you just clearly look at the pattern, what we realize is that each of these values, each of these coefficients is nothing but the formula C and K. So if I want to find a coefficient of a term, right, it's going to be whatever row it is, so whatever the power of the x plus y term is, and it's going to be the n value would be that, and K would be the index. And by index, I mean where it is placed in the formula position, right? So for example, if we take a look at this term, there are two terms. This is index 0 and this is index 1. In this formula, this is index 0, this is index 1, this is index 2. In this case as well, this is index 0, this is 1, this is 2, this is 3, and sorry, yeah, this is 3. So the idea is that any coefficient term, if I'm trying to find it, would simply be n, this is going to be n. So C of 1 comma 0 would give me this term. C of 1 comma 1 would give me this term over here. And I can try doing this again and again for all the terms that I have on the board. So my idea is that any coefficient, we have kind of found the pattern for the coefficients right now, right? Any coefficient is simply the formula C and K, where n is the power of x plus y term, and K is the index of the term, and index in this case starting at 0. Okay, you can also try to find it and try solving a few of these terms on your own too to understand it further. Okay, so that's one pattern that we notice, right, from these four terms. Now let's try to take a look at another pattern, right? Another pattern I notice is that, let's take a look at this, right? In the first term, I had 1x plus 1y. Okay. In the second term, I had x squared plus xy plus y squared. So what I kind of see is that I had x squared, then I reduced the power of x to 1, and then I added 1y, and then I removed x entirely, and then added y squared. In the third one, I had started with x cubed. I had x square y, then xy square, and then y cubed. So one thing that I notice is that every time these xy terms together, their power is actually 3. So which is equal to the n term. So x cubed, x square, y1, 2 plus 1 equal 3, x1, y square, 2 plus 1, 3, and y cubed is 3. So each time, the first thing that I notice is that it's basically just the sum of n. And the second thing is that I start with x to the power of 4 or x to the power of n, and then I keep reducing the value of x and I multiply more and more y's. So I started with x cubed, reduced 1x and added 1y, reduced another x and added another y, and that's what's kind of happening again and again. So I hope you guys understand all these three patterns that I just noticed. Let me just try to quickly explain all of them, right? Okay. The idea is we are trying to find the binomial formula on our own, right? And what I did is, I told you the goal is to expand this for any n without multiplying by hand. Now, this seems easy for the first 4 terms, but if we want to do it for 25, x plus y to the power of 25, we can't just do it by hand. For that, we need to find some patterns. So the first pattern I notice is, if I take down the coefficients of these first 4 terms, it gives this pattern C and K. So where each coefficient is just Cn, where n is the row number and k is the index number. Second pattern I notice is that these coefficients, they sum up to these values x, y, their powers add up to n. So x is cube is equal to n. X square y1 is equal to n. So 2 plus 1 n, 1 plus 2 n, and then y to the 3 is n again. Third thing I notice is that I start with x to the power of n, and then I keep reducing 1x and I multiply one more y. So those are my 3 patterns, and now let's see the actual formula. Okay guys, now let's take a look at the binomial theorem, right? Now we will just take a look at the formula. So I explained you guys the patterns. So this is what those patterns result in. X plus y to the power of n is simply the sum of c n comma k multiplied by x n minus k multiplied by y to the power of k. And the k is actually the index once again. N is the power of what x plus y term is, and this is the final term that we get. Okay, so once again, the idea is very simple. This c n comma k is the coefficient. right? These are just the xy terms that I just explained you guys. Now let's take a look at the pattern, right? So you see this is happening, it's showing xn minus k multiplied by yk. Just like I told you guys, right? Xy term, they together add up to n, right? And whenever we keep on moving in the sum, so whenever you increase the value of k, it keeps on subtracting from x and we keep on adding it to y. So first it will start with, let's say if it is 4, then you'll start with x4, then it goes down to x4, then it will be x3 comma y1, then it will be x2 comma y2, and it will keep on going, right? And that's exactly what this denotes. It denotes that whatever the k term is in the sum formula, you'll keep on subtracting it from x and you'll keep on adding it to y. And this c and k represents the coefficient of each term. So the first coefficient would be, since this is index 0, it would be c comma 4 comma 0. For this one, it would be c 4 comma 1, and it keeps on going until the very end. Okay, so every term, this is the general term, so every term simply has the shape c n comma k into x n minus k y k, right? That's what I'm trying to explain here. So you can see it, I've given this example over here for x plus y to the power of 4. So for k equals 0, it is c 4 comma 0 multiplied by x4 multiplied by y. c4 is simply just 1, so this should be y to the power of 0. So it adds up to x to the power of 4. Same for the second one, same for the third, and for the third and fourth as well. Okay, so I hope you guys are able to understand this binomial formula. Now we need to actually understand why the coefficient is this value cn comma k, right? Like why, how does it end up being this? Like I didn't explain that until point, right? For now, I just gave you guys the formula and why, like what the term is. Now let me guys show you like an explanation first and then animation to explain what that means. Okay everyone, now let's try to understand why are the coefficients, the formula c n comma k, right? This can be probably confusing because the bracket and the c are kind of very similar terms, so I'll just try to be I'll try to make it as clear as possible, right? Okay, so for now, let's just consider that you have this term, right? X plus y to the power of cube. I can write it as x plus y, x plus y, x plus y. Now think about what every term looks like, right? Every single term is pretty much like this, right? I can say it could be x, 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 it could be x, y, x, it could be x, x, y, it could be it could be x, it could be y, y, y. Think about this, right? Whenever you're multiplying this, you pick a term from the first bracket and then you multiply it from the third two. So from each of these brackets, the basic idea is you're picking one term. So from this bracket, I'll pick either x or y. From the second one, I'll pick either x or y. And same thing I'll do for the third one too. So I'll pick either x or y, right? So let's say if I pick 3 x's, it would result in x cubed. We're not worrying about the coefficient for now. Just take a look at the terms that we have, right? Okay. Second, another way is that I have 2 x's and 1 y. Third way is this is actually the same thing, so it doesn't really matter. We just care about the count. So one way could be the y cube, right? But the idea is very simple, right? Now let's try to imagine it in this way. Think about these x plus y's are actually 3 empty boxes. And each of them you can either put x or y, x or y, x or y. So you're simply putting x or y into each of these terms, right? So you have two options, x or y, and you need to put into, you can repetitively put them into these terms, right? And that's exactly what you're doing. So 3 boxes, you can put x or y. I can put x, y, x. I can put maybe 2 y's in this case, or I can put 3 y's if I want to. And this is the reason, and this is exactly one of those problems that we did when we were doing combinations, right? This empty box problem is actually a combination problem. So now let me show you guys this with the animation, right? But I hope you guys kind of get the idea. we wrote x plus y cube as x plus y multiplied by x plus y multiplied by x plus y. The idea is that from each of these brackets, you're picking one term, right? You're picking either x or you could pick y. So one of those terms could, in result, would be xxx, it could be xyx, and it could be 3y's. So imagining this as empty boxes where you're supposed to pick either x or y value turns it into a combination problem. And that's exactly where the formula C and K comes from. So now let's actually see this with the animation. Okay, guys, so if you have x plus y cubed, right, think about each of these terms, x plus y, as a box. For each one, you're picking a x or a y. So you can pick x, x, y, which gives you x square y, or you can pick x, y, x, giving you x square y again, which is the same result, right? Now, the entire point is this way you get 8 different ways. Now, I've given them all in this animation over here. You can pause and take a look. So 8 is basically 2 to the power of 3 in total, right? Now, if you group by results, right, you get 1x cube, 3x square y, 3xy square, and 1y cube, which is the expansion of x plus y. Now, the insight is that for each of these boxes, you're trying to find out which one gets the y, right? Which box gets the y. That is using the combination formula. So in general, what you're doing is, if you have n boxes, you're choosing which k boxes get y, which gives you the Cn comma k formula. Okay, everyone. So now I've given this question on the board. I hope you were able to understand the animation. And now let's take a look at this question, right? So the idea is you've been given this equation, 2x minus 3y to the power of 25, and you're asked to find the coefficient of x12 to the and y to the power of 13. Okay, so once again, now if this was like, if you didn't have the binomial theorem, this would be a very tricky question to solve. But since we know the binomial formula, let's just start using it, right? Okay, so given the formula 2x minus 3y, let's first write it as a equal 2x, b equal minus 3y. Okay, so I'm just representing a with 2x, b with minus 3y. This gives me a minus b, sorry, a plus b 25, right? Now this becomes the binomial formula that we already know. So we need to find the coefficient for x12, y13, right? So since we are supposed to find the formula for this, if you remember, the binomial theorem was Cn comma k multiplied by x to the power of n minus k, y to the power of k, right? Okay, so how about I just replace this? Based on this information, what do you think the value k would be? The value k would simply be 13, right? X is 12, y is 13, add up to 25. So that means this total n is adding up to 25, that's correct. And k in our case is the value 13. So what would be C and k? C and k would be C, n is 25, and k in our case would be 13. Okay. Now, why did I replace this with a plus b? Because we didn't really have a x plus y term. We had a 2x minus 3y term. So I replaced it with a plus b kind of a term, right? So this becomes C 25 comma 13. I can write this as multiplied by a to the power of 12 and b to the power of 13, right? I can simply write it this way. So once again, just a quick idea. I represented a equal to x and b equal minus 3y, which gives me the binomial formula. This can be written as, if I need to find the term, this can be written as C25 13, A12 into B13. Now let's just replace A and B with the actual values that they represent. So this would be C 25 comma 13 multiplied by A in our case was 2x, so it would be 2x to the power of 12 multiplied by B, which is minus 3y to the power of 13. Okay, now the question asks what would be the coefficient of this term. So it would be this term, C25 13. Take the 2 out. So if we take the 2 out of this term, it would be 2 to the power of 12. That would give us 2 to the power of 12. And if you take the 3 out of this term, that would be minus 3 to the power of 13. And this would be your coefficient. Okay. So the trick for this type of a question is very simple. Just whatever the term you have been given, represent it as a B term, right? A plus B formula. Turn it into whatever the actual, represent it with the binomial theorem, and then represent the A and B values with whatever they actually represent, giving you the coefficient value. Now remember, the coefficient wouldn't have simply been this term, because these x and y values, they also had the 2 and 3 coefficients too, right? So don't forget to just solve this and say that C 2513 is the final answer. We also had this 2 term and this minus 3 term. So the final answer was C 2513, 2 to the power of 12 multiplied by minus 3 to the power of 13. And that would be with x 12, y 13. So this would be your next term, right? Okay. So I hope you were able to understand this, and I hope you guys were able to understand the binomial theorem. Now I'll be giving a bunch of questions on the board, and then we will move on to the next lecture. Okay, everyone, I've given these 3 questions on the board, so pause the video and try to solve them. Okay, so I'm not going to solve the first one. I think that's the example that we just solved. All you have to do is just use the formula C, n comma k. N comma k multiplied by x to the power of n minus k and y to the power of k, right? This is the formula. All you have to do is just plug in the values. Okay. We're going to try to solve the question number 2 and question number 3, because these are the actual tricky questions, right? Okay. Find the constant term in this value, which is x plus 1 by x to the power of 10. Okay. First, let's try to actually understand what does it mean by the constant term. Constant term basically means wherever the x to the power is 0, right? So think about this, right? There's only one variable in this, which is x. So the question is saying, when you actually expand this term, and what's going to be the constant term, like when it's going to be x to the power of 0, and what would be the constant next to it, right? That's what we are trying to find. So let's just quickly try to solve this question, right? Okay. So let's represent x as a, right? And 1 by x as b. I can write this as a plus b to the power of 10, right? And a plus b to the power of 10 can be written as c 10 comma k multiplied by a to the power of n minus, sorry, I should say 10 minus k b to the power of k, right? I can simply represent it with this. So if I just replace it with the x and y term, this can be c 10 comma k x to the power of 10 minus k and 1 by x to the power of k over here, right? Okay. What happens when I actually 1 by x to the power of k is the same as x to the power of minus k, because x is in the denominator, right? So I can write this term over here as x to the power of minus k. Okay, so let's just take a look at this term over here, right? Let's just try to grab it. So we get x to the power of 10 minus k multiplied by x to the power of minus k. What happens when you combine them? You just add the powers. So this will give you x to the power of 10 minus k, which would be x to the power of 10 minus 2k, right? Okay, let's get back to the question now. Question is saying, find the constant term in it, right? What would be the constant term? Constant term would be the place where x would be something to the power of 0. That's where we wouldn't have any x term, and that would result in a constant term. So that would mean that we need x to the power of 10 minus 2k to be equal to x to the power of 0. So 10 minus 2k, we need it to be 0, right? And this gives you 2k equal 10, k equal 5. So your k term would be 5. Now all you have to do is just replace it with this over here. So what do you get? You get c 10 comma 5 multiplied by x to the power of 10 minus k is 5 and x to the power of minus 5. These cancel out, so your final answer is simply c 10 comma 5, and this would be your answer to this question. Okay, now let's move on to the final question. I hope you were able to understand this. I would say rewind back and then I think watch it again. The idea is very simple. It's just, I think the understanding the question is the difficult part. Constant term basically means that whatever the expression is, what would be that term where x and x cancels out? There's no x. So that's why we set the power of x to be 0, right? Okay. Find the coefficient of x4 in x plus 2 to the power of 10. So once again, let's just write it with a, b kind of way, right? So I can write this as c n c10 comma k equal x n minus k 2 to the power of k. Okay, now first thing you might notice is that replace this value 4 with the value k, but that would be incorrect, right? This 4 is the value of the x in this case. So that means the value n minus k is actually 4. We're trying to find the coefficient of x to the power of 4, right? So that means the value n minus k, this in our case we want it to be 4. So n minus k 4 means 10 minus k equal 4. That means k is actually equal to the value 6 and not 4, right? It is probably possible that some of you might have made the mistake of setting the value 4 to be k, but that is incorrect. Okay, so k is actually the value 6 because we're talking about x to the power of 4. And in the formula, you actually multiply x to the power of n minus k. Okay, so once again, we have the k value now, so that the formula would be c 10 comma 6 multiplied by x to the power of 4 multiplied by 2 to the power of 6. So the actual term would be c 10 comma 6. I'm sorry, my marker is not working really, so but it would be this multiplied by 2 to the power of 6, and this would be your answer. Okay, so I hope you were able to solve these questions, and let me know if you guys have any doubts in the comment section or any mistakes I made. I really hope you guys are liking the animations, and if you guys really like my content, I would really appreciate any feedback. Okay, I'll see you guys in the next lecture.